Hello everyone, welcome to my channel. If you are new to my channel, please subscribe to my YouTube channel, so you can join our tech family. If it is informative to you, please like our video, share it with your friends so they can get help with these video, and don't forget to press all notification bell icon so you get regular update and don't miss any single video.
Imagine you have around 100 routers and switches across your network, and all the links that go with them. Everything's running well, and you're thinking about having the day off. But then, everything starts to slow down. People are complaining that phone call quality is poor, and they can't access the internet. And guess what? It's up to you to figure out which of your 100 routers, switches, or links is the problem. What tools will you use to solve this? Of course, you have logs on your syslog server, but wouldn't it be great if you had a server that monitors the health of your network? You could find your problem, or maybe you could even see the warning signs before you even have a problem. And that's what SNMP, or Simple Network Management Protocol, is all about. It's a protocol that enables you to monitor and manage the health of the network. A management server will use SNMP to collect information about devices on your network. This can include details like link speed, CPU and memory usage, temperature, fan speed, and many more. One simple way it does this is through a process called polling. At regular intervals, which could be every few minutes or every few seconds, the management server will send out an SNMP message using UDP port 161 to the devices that it manages. This message asks each device questions about its current health, and the devices respond with their answers. Polling is very proactive, as you can see the status of your devices at any time. The other way this can work is with SNMP traps. This method does not rely on the server to frequently send messages out to the network. Instead, when devices have something worth reporting, perhaps a fan has stopped spinning or the CPU is getting too hot, it will send an SNMP trap message to the management server. Traps are very reactive, as they wait for an event to happen before notifying the server. We don't have to choose between polling and traps though. We will generally use a mixture of both. Now that the server has this information, there's usually a few things it will do. It will record the information for historical use. For example, we might want to see what our peak time periods for internet usage are. It will provide information to us in the form of graphs, charts, and so on. This might include the percentage of uptime across our network, for example. It can provide a web-based dashboard with the overall health of the network. Sometimes this might look like traffic lights, where green means healthy, orange or yellow is a warning that something's not right, and red indicates a definite problem. And it will also send us alerts when problems occur, or maybe even if it's predicting a problem. For example, we might get an email saying that a file server has less than 10% disk space left. This is a case where we can fix an issue before it becomes a real problem. Let's look a little deeper into SNMP. In particular, we're going to look at MIBs and OIDs. A MIB, or Management Information Base, is a hierarchy of information that describes components of the device that we want to manage. The way it's organized is a bit like a name in DNS. We start with a root node, which has a child node, that node has a child node, and so on. This simple structure here is how most MIBs start. After that, it gets more specific. Some of these trees can get extremely specific. A vendor like Cisco will release MIB files which you can download from their website and install on your management server. The MIB file contains information about how to use this hierarchy for their product. When we follow a branch of the MIB hierarchy to the end, we find an object. This will have a name, but it is also represented with a number. This number is the object identifier, or OID. The one we're showing here is used to get information about CPU usage on a particular Cisco router. See how each number represents a level in the hierarchy. There are a lot of OIDs covering all aspects of the device we want to manage. The sheer number of OIDs is why we need to organize them neatly into their MIB hierarchy. So, do you need to remember these OIDs? Do you need to work with them on a daily basis? No, not really. Once you install a MIB file on your management server, it handles 99% of the job for you. It's a rare occasion that you will want to manually work with OIDs. So, in short, A MIB is a hierarchy of objects. These objects tell the management server and the device how to share information. MIB files are downloaded and installed onto the management server. There are different MIB files for different devices. For example, a printer's MIB file might contain information on how much toner is left, while the MIB for a switch will have information on interfaces. Devices configured with SNMP also have a community string. This is simply a label that belongs on the device. For example, we might configure our routers with an SNMP community called routers. Our servers might have the string servers, and our firewalls might have the string Cookie Monster. Yeah, it really doesn't matter what we want to use, but it should make sense. A device could even have more than one string if there was a good reason for it. So what's the point of the community string? When a management server polls a device, it sends an SNMP message on UDP port 161. In this message, it includes the community string that it's trying to access. If it provides the wrong community string to our device, the device won't respond with any useful information. So in this way, it's kind of a password. Unfortunately, this password is not encrypted in the message or in the configuration on the device. There's not much more to strings really. The only other thing I have to say is that most community strings are used for read-only access to the device. That is, to collect information for monitoring purposes. But we can also configure read-write strings. This enables the management server to configure our devices. This is much less common, and honestly there are usually better ways to configure devices from a server. So in general, I don't recommend using them. There are 3 versions of SNMP, and sometimes there's slightly different configuration involved. The original SNMP is version 1, as you would expect. Everything we've discussed so far, like community strings, OIDs, and MIBs, all apply to version 1. However, there's a problem with version 1. All the objects in version 1 were 32-bit only. This doesn't allow for very large numbers when you're counting something like the number of packets that have passed through an interface. So, version 2C was released to add support for 64-bit numbers. Everything else is the same though. It still uses plain text community strings, for example, which isn't as secure as we'd like. So, along came version 3. This now has support for authentication, using a real username and password, as well as encryption to keep everything secure. This makes it so much harder for a bad guy to use SNMP to steal information about our network. So, for security, you really should be using version 3. Version 2 is still very common, so if you must use it, at least choose your own community strings rather than using the defaults. It's easy for a bad guy to use the defaults and collect information about your network. Also, lock down the IPs that your device will accept SNMP traffic from. This is usually only the management servers. Requests from other IPs that aren't listed will be rejected. And finally, disable SNMP write access unless you really decide that you need it. If a bad guy does break in, then at least they can't use SNMP to reconfigure your network. Before we move on to the lab, here are some questions just to see how you're going. So, let's look at some basic config. We're going to configure version 2. I know I just said that version 3 is better for security, but version 2 is simple to get started with for learning purposes. This is pretty easy to get into. Everything's based around the command SNMP server. There are plenty of options here. We're going to start with the community string. Our string will be called routers. After that, we have to decide whether this will be read-only or read-write. I've already shared my opinion on this, so I'll set this to read-only. Next, we set the host IP of anything that's allowed to poll this device. After the IP, we set the version, which is 2C for our demo. And finally, the community string that this IP is allowed to poll. For completeness, let's have a look at trap configuration. Traps can be enabled for all sorts of things, as you can see, but for this demo, we'll simply set config. This lets our router send a trap when changes are made to the configuration. Our router config is now complete. Time to test it out. For this demo, I'm making use of a simple and free SNMP tester tool that you can use as well. It's not a full management server, but it can perform simple SNMP polling just to check that it's working. There is a link in the description if you'd like to use it yourself. We're going to set the IP that we want to poll, set the version to 2C, and the community, which is routers. For our first test, we're going to send an SNMP message to scan the device interfaces, and we're going to click Start. This returns a ton of information to us. The tool is sending a query using some generic OIDs that apply to nearly any network device. Notice over here that it has discovered the interfaces on our router. Of course, we can send a request using any OID that we want. Here is one that I found after doing some research on the internet. This should return the router's hostname. So we'll enter in the custom OID and we'll click Start. And you can see over here that it is successful. It has discovered that our device's hostname is R1. Practically, you don't often need to mess around with custom OIDs.
We hope you enjoyed the video and found value in the content. We value your feedback. If you have any questions or suggestions, feel free to post them in the comments section or contact us directly by our social platforms. Thanks for watching.